Hi, this is Dr. Eddie Morgan at Clovis East High School, and we're going to work today on our homework help for your homework worksheet 1.3. Remember, each of these questions is very similar to the exact question on the homework. So if you have a homework problem you don't quite understand, look at the corresponding problem here, watch us work this, and you should be able between the two to figure out how to do the problem on the homework. So let's get started. In the first problem, you can see we're just getting into a little more complicated equations to solve. They're not that complicated, they just require more steps. You just have to kind of be looking and seeing things. And first step we always do is look on both sides. So if I were to draw a line here and separate the left side and the right side, I would look and say, is there anything that I can combine? Well, I do notice that I have on this side a 3 minus a half. So if I wanted to, I could at this point combine like terms. And in this case, the like terms have the same variable part in that they don't have a variable at all. So I would have 5d plus 6 equals 3 minus a half is 2.5 plus 5d. All right? Now we have a situation in which we have variables on both sides, and often what we want to do is subtract variable from both sides to get one side without a variable at all. I usually pick the smallest absolute value and subtract it. In this case, they're both 5d's. So what I'm going to do to eliminate the variables is I'm going to subtract 5d from both sides. Now notice I subtract 5d here and 5d here. I can do this by the property of the subtraction property of equality. Now notice what happens in this particular problem. When I do 5d minus 5d is 0, likewise on the other side, and I end up with this statement, 6 equals 2.5. Now you look at that and ask yourself the question, when does 6 equal 2.5? And the answer is never. So I do not have a solution. That means that in this case, I've set up an equation in which there is no solution. So my answer would be no solution. In other words, there is no value that I can give to the letter D that will ever make this statement true. And so we say this is no solution. In the second one, first thing we notice is, as before, we need to get rid of this parentheses here, so we're going to use the distributive property right here to get rid of the parentheses. So I'll write down here that my first step is to use the distributive property. And so on one side I have 4a plus 1 equals, and then I have minus 4.8 times a, subtract, and then minus 4.8 times 1. So if I simplify that, I have 4a plus 1 equals minus 4.8a. Minus times a minus is plus 4.8. Okay? Now, we have a variable on both sides, so we want to get rid of that. We could either subtract 4a from both sides, or we could add negative 4.8 to both sides. And since I wanted to keep this positive, I'm going to get rid of this one here by adding 4.8a to this side. And whatever I do to one side, I have to add it to the other as well. And of course, doing this, I'm using the addition property of equality. Minus 4.8 plus 4.8 is 0. And over here, 4a and 4.a add up together to give me 8.8a plus 1 equals 4.8. And now you see we have a two-step equation. So we need to undo the 8.8 times a and then the plus 1. We usually start by undoing the addition or subtraction. So the opposite of adding 1 is subtracting 1. So that is 0, and I end up with 8.8a equals 3.8. And this operation, I could do this because of the subtraction property of equality. Okay. Then in our next one, to undo 8.8 times a, the opposite of multiplying by 8.8 is to divide by 8.8. So we divide both sides by 8.8. 8.8 divided by 8.8 is 1, and leaves me a. And this is the multiplication property of equality. And then get out my calculator and take 3.8 divided by 8.8. And I end up with something like 0.431818, and it keeps going on and on and on and on. And or I could just round that off to a is about 0. If I round off here, that's not 5 or bigger, so I would just leave it as about 4.3. Other alternative would be to try to reduce the fraction down. I see that I could take a 2 out of there and get 1.9 over 4.4, but that's not necessary. Okay, so we have a solution, and in this case there is a solution to this one. Okay. Let's move on to the next. The third problem is similar to problem 2, and then what we need to do is we look at it. On the right side we have parentheses that we need to eliminate using the distributive property here. So this is the distributive property that we're going to use. And the one side stays the same. 0.5b plus 6 equals 3 times b plus 3 times 2, which is 6. Okay. Now, if you wanted to at this point, you could say, I don't want a decimal here. So to get rid of the decimal, I would multiply by 10. That would move the decimal point to the right. But to do that, you remember you have to multiply everything, both sides, by 10. So I'm going to use the multiplication property. Of equality. And just remember, I'm multiplying that side by left side by 10. I'm also multiplying that side by 10 if it helps it easier to see that. And then you see you distribute it through here as well as distribute this through here. So 10 times 5/10 is going to be 5b. 10 times 6 is 60. And then 10 times 3 is 30b. And 10 times 6 is 60. So usually what we do is gather all the variables on one side or the other. I usually pick the smallest coefficient of b to subtract. So 5 is less than 30. And so we'll get rid of the 5b on the left side. So subtract 5b here. But to keep things in balance, I have to subtract 5b from the other side. And this, of course, is our subtraction property of equality. Subtracting 5b from 5b gives me 0. That gets the variable on that side and moves them all to the right side. 30 minus 5 means 25b, and then I have the plus 60. Correct that for you. Now we have a two-step equation. b is multiplied by 25 and then add 60. We usually simpler to undo the addition or subtraction first. So the way to undo plus 60 is subtract 60, and whatever we do to one side of the equation, we have to do to the other side. This is once again our subtraction property. $60 minus 60 is 0. Also over here, so I end up with 0 equals 25b. Now last step, to undo b times 25, the opposite of multiplying by 25 is dividing by 25. That's 1. And that is, of course, our multiplication property. And you notice that this is 1. 0 divided by 25 is 0, so b equals 0, or if I turn it around, b equals 0 is my answer. Okay? So this one has a solution, b equals 0. Number 4, you notice we're going to have to distribute both sides. So I'm going to do 6 times m, 6m, 6 times 1.5. That's going to be 9. And then 1.5 times 4 is going to be 6m. And then 1.5 times 6 is going to be plus 9 again. Okay? And this was, of course, using the distributive property. And now you notice here, let's start by getting rid of the variable. I have a 6m on both sides, so if I subtract 6m from both sides, you may already begin to see what's going to happen here. This is doing the subtraction property. Of equality. 6m minus 6m is 0. 6m minus 0. And I get 9 equals 9. Now here's the question I ask. All the variables are gone. When does 9 equal 9? When? All the time. And what we're really saying in this equation, because the variables were eliminated, is it doesn't matter what you put in for m, you're always going to get a true statement, 9 equals 9. If you put m equals 0, you'll get 9 equals 9. If you put in m equals 1, 9 equals 9. And so in this case, this is what we would call an identity. When it's true all the time, it's called an identity. So the answer to this problem is it's an identity. Remember in our earlier problem, we ended up with that 6 equals 2.5, which never is true, and that's the no solution. But this is when you get a true statement that's true all the time, then you have an identity. Problem 5 gives us a problem and says they've made an error. Can I figure out what the error is? Well, let's just start solving it and see what we can come up with. They said there was no solution. We start with 3x equals 9x. Well, what they decided to do was divide by x. Okay? In my case here, I wouldn't divide by x because what if x is 0? That could give me a solution. And they got 3 equals 9. Instead, let's treat this and say, let's get the variables on one side. So 3x is less than that, so I'm going to subtract 3x from both sides. That gives me 0 here. So 0 equals 6x. Now we undo this by undo 6 times x by dividing by 6. And we end up with a solution that 0 equals x, or I can turn around and say x equals 0. Does that work? Let's just check it out. Does 3 times 0 equal 9 times 0? That's our question. Yeah, 0 equals 0. So that means this is a true solution. X equals 0 is a solution. Notice that by dividing by x here, we eliminated the variables and got 3 equals 9. But that's still not a good solution. By the way, notice there is a little typo in our problem here. This should have been 3x equals 9x. Okay? Next problem. Here we have a word problem. A skier is trying to decide whether or not to buy a season ski pass. A daily pass costs $68. A ski season pass costs $405. Either way, he's going to have to rent skis for $35 per day. How many days would the skier have to go skiing in order to make a season pass less expensive than a daily pass? So what we're looking for is the number of days. So I'm going to let X equal the number of days I go skiing. Okay? So if I'm just going on the daily pass is going to cost me $68 times each day plus 35 times each day. The pass is going to cost me just one amount, $405, and then 35x. So what we want to do is we want to find out how many days it would take the skier to make the season pass less expensive. So let's think about this in terms of when would they be equal. Okay, so I'm going to set this equation up and says when is 68x plus 35x going to equal $405 plus 35x. All right, so first thing we're going to do, let's combine terms here. I'll combine those terms, and 8 plus 5 is 13, carry the 1. 103x equals 405 plus 35x. So now let's get all the variables on one side. So 35 is smaller than 103, so let's subtract 35x from this side using the subtraction property, and we get 68x equal 405. Now some of you may have seen that right up here. You could have seen it, well, it doesn't matter. We don't even need to worry about how much it's going to cost to rent per day. Those are subtract out, and we could have just immediately seen this. So now the cutoff date is to undo 68 times x. We're going to divide by 60. And that gives me, get out my calculator. And I end up with x is about 5.95588 number of days. So in other words, it's going to be cheaper to do the daily up until I get to 5.9 days. All right. So at the point at which x equals 6 days, once I go to 6 days, that's when the daily pass will be more expensive. So this person has to think about it and say, well, how many days am I going to go skiing? If I'm only going to go skiing 1, 2, 3, 4, or 5 days, then I might as well just go ahead and buy a pass every day. If, however, I'm going to ski more than 6 days, then I'm going to go ahead and buy the pass. I had friends when I was in high school that their parents would always get them the ski pass before Christmas, knowing that they would go up during Christmas vacation and usually get their money's worth just on Christmas vacation, and then the rest of the year was kind of free to them. So the answer there would be 6 days. If you're going to ski more than 6 days, buy the pass. Number 7 is another one. One health club charges $50 for a sign-up fee and then $45 per month. Another club signs up $80 sign-up fee and then $35 per month. How many months is it that they're equal? Okay, so let's set it up. Health Club A, I'm going to call it. You have to pay $50 to sign up, and then each month you pay $45. Here I'm going to let M equal the number of months. The second one, they charge you $80 to sign up, but then they're less per month. And the question is, when are these two equal? Well, let's just set them equal and find out. So I'm going to put down here 50 plus 45M equals 80 plus 35M. We have a variable on both sides, so we need to subtract it or add it from one side to eliminate it. 35 is smaller than 45, so since I like positive numbers, I'm going to subtract 35 from this side, and whatever I do to one side, I have to do to the other. So that eliminates it from that side and kind of moves it over. Remember, you just can't go, oh, I'll put the 35 over here and add them. Now I have to subtract it from both sides to get it. So now simplify that. We have 50. 45 minus 35 is 10m equals 80. And now we're back to our two-step equation. So we're going to undo first the plus 50. So subtract 50 from both sides. Subtraction property. That's 0. So I have 10m equals 30. And now undo 10 times m by dividing by 10. The multiplication property of equality. And I get m equals 3. So if you when you go 3 months, it doesn't matter which one you sign up for first. And before that, if you go 1 and 2 months, one health club is cheaper, and then after that, the other health club is cheaper. So, but at 3 months, they'll be equal, and that's our answer: 3 months. Now, number 8 says the perimeters of triangles shown are equal. Find the side lengths. Well, perimeter is how far is it around. Perimeter is the distance around. If you started at one point and walk around, they're the same. So the perimeter is the distance around. So the first triangle here, the perimeter here is, let's add them up. Let's see, I'm just going to say the perimeter of PQR is 2x plus 2x plus 4x plus 2. And the perimeter of ABC, add them up, is 3x plus 3 plus x plus 2 plus 3x plus 4. And then they tell us that these two are equal. So let's set them equal. Let me write it all out here again. First one, 2x plus 2x plus 4x plus 2 equals 3x plus 3 plus x plus 2 plus 3x plus 4. And now, simplify this, we just need to add all the like terms. Notice here I have 2x plus 2x plus 4x. 2 plus 2 is 4 plus 4 is 8x plus 2. Just combining like terms. Here I have 3x plus x, that's 4x, plus another 3x. So 3 plus 1 is 4 plus 3 is 7x. And then we add here, we have 3 plus 2 plus 4. So 3 plus 2 is 5. 5 plus 4 is 9. Okay, almost to a two-step equation. Notice that I have a variable on both sides. So I'm going to take the smaller one, the 7x, and subtract it from the right side. So I have to do the same from the left side. That's the subtraction property of equality. 7x minus 7x is 0. Notice I've moved it away. 8x minus 7x is 1x. So I have x plus 2 equals 9. Almost there. Undo the plus 2 by subtracting 2. 2 minus 2 is 0, so I have x equals 7. And so our answer is x equals 7. Now they want the length of each side. Well, to find the length of each side, you're going to have to plug this into each of these. So 2 times 7 is going to be 14. 2 times 7 here is 14. And here we have 4 times 7 is 28 plus 2 is going to make this side 30. Okay? Now up here, 3 times 7 is 21, plus 3 means this one's going to be 24. 7 plus 2 makes this 9, and 3 times 7 is 21 plus 4 is going to be 25. Now let's check our answers. Okay? 14 plus 14 plus 30 adds up to 858. On the other hand, 24 plus 9 plus 25, 9 plus 3 is 13 plus 5 is 18 plus 1, 58. And notice that's the correct answer. The perimeters of those triangles are the same when x is 7. Problem 9 is a business question. We have a small juice company that spends $900 a day just for business expenses. That's administrative expenses. That could be things like, you know, the rent on the building of the warehouse, the what they pay people to work, those kinds of things. But they also spend very specific $1.20 per bottle of juice that they make. Okay, the $900 they're going to spend every day no matter how much juice they make, whereas the $120 depends on how many juice bottles they decide to make. At the same time, they charge $2.50 for each bottle. They want to know how much do they have to sell each day just to break even, so that how much money they make, $2.50 per bottle, is the same as how much money they cost. So on the one hand, let's look at the cost. Every day the cost costs them first $900 plus $1.20 times the number of bottles. So I'm going to let X equal the number of bottles. So it's going to cost them $900 plus $1.20 times each bottle they make. On the other hand, their revenue here is they make $250 times each bottle, or $250 times X. Okay? Now, in this case, you could do this just directly if you don't have a problem with decimals. If you don't like decimals, you could look and go, well, I don't like the decimals. So to make, this is 1 in 20 hundredths, this is 2 in 50 hundredths. So if I multiply everything by 100, I can do that by the multiplication property of equality. I'll get rid of the fractions. Just be careful here. 100 times 900 is going to be 90000. It's going to be 90,000 plus 120x. And remember, multiplying by 100 moves it twice. And same here, equals 250x. So now all I've done is change the problem so there's no decimals. Now we have basically well, not a two-step equation yet. We have variables on both sides. So I picked the smallest one, 120, and I'm going to subtract that from both sides. Remember, we can't combine terms across the equal sign. We have to do this adding and subtracting it to move it along. This is 0, and so we end up with 90,000 equals 130x. And now to solve for x, we undo x times 130 by dividing by 130. That's 1. And pull out my trusty calculator. 90 divided by 130. And I get 692.307 about equals x, or I could say x is about 692.3 bottles. That's when they're equal. All right. So if I want to know how many bottles I have to make in order to make money, I would say my answer is 693 bottles. If I make 693 bottles, I'll actually make a little profit. If I just make 692, I'll still lose a little money. So they need to be looking at, you know, this is a company that probably looks and says, in rounding off even bigger, I might say, hey, we need to at least make about 700 bottles a day just to cover our costs. The last problem here, you set up a spreadsheet to solve this, and what they've done is they've put an x here, and then they put the 5x plus 1, which is this side, and the 3x plus 1, x minus 1 on that side, and they're just putting in different values of x to find out when are they equal to each other. And so you'll notice that when we put in -5, b is smaller than c. We put in -3, b is now bigger than 3, and notice that at this point there's 6 difference and it's getting bigger and bigger. The question is, does the spreadsheet show the solution? And the answer is no, in the sense that we're not seeing a value for x where b equals c. The next one, though, is important. Between which two values is a solution? Well, notice here that negative 20 is less than negative 18. But then when I go to negative 3, negative 10 is greater than, so that's where the shift occurred. So we would say the answer to that is between x equal minus 5 and x equal minus 4. And how do I know that? And I said that I know that because the answer switched from less than to greater than between that two. For what spreadsheet values is x is 5x plus 3 less than that? And you see anything from 5 and below, so the answer is for x equal minus 5 at x equal minus 3. So we would expect our answer is probably sitting in there, close to minus 4. It may not be an exact number. I mean, it may not be an integer. And so this is the one that's less, x equal minus 5. For these, it's all greater than. Okay. All right, thank you. I hope this helped you today.